Hello, this is editorial for Codeforces Global Round 27. This problem is sliding. Now, there are n rows of m people. Let the position of in the ith row and cth column be denoted by r, c. Number each person starting from 1 in row major order. That is the person numbered I minus 1 times m plus c is initially at r, c. The person at r, c decides to leave. To fill the gap, let the person who left be numbered I. Each person numbered j more than I will move to the position where the person numbered j minus 1 is initially at. The following diagram illustrates the case where n minus 2, m minus 3, r equals 1 and c equals 2. Here you can see the diagram. Now, calculate the sum of the Manhattan distances of each person's movement. If a person was initially at r0, c0 and then moved to r1, c1, the Manhattan distance is r0 minus r1's absolute value plus absolute value of c0 minus c1. The input constants are also given here, and here is the sample test case. And we are asked to find for each test case output a single integer denoting the sum of the Manhattan distances. So let's try to figure out a solution. Here on my right side you can see that I have illustrated a matrix of n n by m people where there are n rows and n columns. Now this person be the person who will be removed. The person is at r, c and he goes away, and therefore the people who follows him will take up his place. For example, the person after him will move one step and take his place, and that will leave a gap here. So the person succeeding him will move one step and take his place. Similarly, this person will take the place of the person preceding him. Similarly, for each of the rows that succeed that come after R will also be arranged in such order. Now let's uh, let's try to figure out how the action works. For example, in this last row, the second person will move one step and take the spot of the first person. The third person will move one step and take the spot of the second person. Similarly, there are m minus 1 people, each of whom will move one step, and that is the Manhattan distance contributed by that person. So there are m minus 1 such people. So the total Manhattan distance contributed by them will be 1 times m minus 1, which is m minus 1. And the person who is at the front of the row will also move m minus 1 times, but he has to move additional one step to go to the next to go to its previous row, which will be plus 1. So the total Manhattan distance contributed by this row is 2m 2m minus 1. Now here you can see that here there are n minus r such rows. So multiply it by n minus r. Let's erase this part. Here you can and using this expression we have found the total Manhattan distance contributed by this r minus r rows. Now in the rth row in this row here are m minus c people who come after the person at r, c. So those people will also move r m minus c steps, and therefore there will be additional m minus c to our expression, and this is the final formula, you can say, and that's the solution. So thank you for watching.